Welcome, grade 12s. Today we're going to look at we're not looking at physics, we're looking at chemistry. We did physics last week. And just like with the physics grade 12s, we're going to do some multiple choice because we can cover a lot of work. And I want to teach you, if I can, how to work through the multiple choice so you don't play multiple guess. Okay, because that's really, really important. So here's the first one. All right, a lot of these are organic, and because I think it's quite important. So here's our first one, and I'm giving you a minute. And just like last week, I need you to, in your own heads, or at least write it down, you need to be able to justify, in other words, explain to me why you chose your answer. Okay, so I need to see something. A lot of these you can work out before you even look at the equation. Okay, so that's really, really important. So now I'm going to give you a minute, and your time starts now. All right, grade 12. So how do we work this one out? Well, what I would do is I would take this and I would actually draw it out. So I'd go, well, I've got CH2, okay. I have a CH, then I have a CH3, so there must be a double bond there. I add it to hydrogen, that becomes CH3, CH2, CH3, double bond disappears. The hydrogens come on, that makes it addition. It's not esterification because I don't have an alcohol and a carboxylic acid. It's not elimination because I don't end up with water and I end up with only one compound. It's not substitution because I didn't end with two compounds. So I know it's not that, so it has to be addition. First one, done. Here we go. Next one. All right, you have a minute and your time starts now. Okay, grade 12. So how many of you are looking at this going, the answer's not there? Well, the answer's always got to be there. We've got to think through this. This O2 is very important because it asks you whether this could be an alcohol, a carboxylic acid, or an ester, or a combination of those. Because it's O2, it definitely can be a carboxylic acid because remember, that is your functional group for carboxylic acid. It definitely can be an ester because we can have the oxygen somewhere in the middle. So now the question is, could it be an alcohol? So if I look at CH4, I've got CH, that's 1, 2, 3. So if we think it's going to be an alcohol, there would be my 4. They want 2 oxygens. So let's put an oxygen, and this would be an H, and this would be an H. So that's already 2 hydrogens. I've only got 8 to play with. So that's 2, 3, 4, 5, 6, 7, 8. I'm missing 2. Do you see there's a problem? And even if I put a double bond over there, that gives me one more. Maybe if I put a double bond over there, I can get another one there. But we're not, this becomes a nightmare. We would never give you a question like this. So this is not an option. It's not going to be an alcohol. Okay, so now we look at the options. Well, it's not only one. It's not one. It's not one. So it has to be D, 2 and 3. Look at the options. Very, very important. All right, next question. You have a minute. Time starts now. Okay, now, it says, which one of the following compounds represent the first member of the ketones? I'm not even going to look at the answer. I'm going to draw it out because I should know this. Remember, the difference between a ketone and an aldehyde is that an aldehyde has to have the double bond to the carbon at the end of a chain. So if I have a single carbon with a double bond oxygen that looks like that, that it has to be an aldehyde. If I have 2 carbons with a double bond oxygen, that also has to be an aldehyde. To make it a ketone, I have to have 3. So that means I'm going to have 1, 2, 3. The double bond to the oxygen cannot be on the end, so it has to be here. Okay, and then we have this. And I've just realized I've got the same answer twice. So some of you are confused. You are correct. I think I made a typing error here. This is the first one, which is actually C or D in this case, because I've got CH3, CO, CH3. Okay, they won't do this in the exams. I typed this incorrectly. I do apologize, so let's just ignore D. The answer is C. Okay, but I worked it out. I didn't even look at the others. Okay, and in fact, this is the methanol, and that one there is methanol. It's an alcohol. Okay, all right. So next question. We're doing great. Here we go. Now I want to know which one of the following is a product of the hydrogenation of ethene. So there you go. You have a minute. Off you go. Okay, so now we look at this and we go, oh, look, we've got this. The thing here is that they've put this in structural formula for us. So now they say the product of the hydrogenation of ethene. So what they're doing is they're saying we've got ethene. Okay, hydrogenation means I'm adding hydrogen to it. So that means it's going to change it into this. Okay, so now we look at this and we go, well, A might be an option, but it can't be. It's an N that makes it a polymer. No. Well, we didn't add in an O, so it can't be B. So we go no. Then we go, oh, look, C and D look right. The problem with D is that it's propene because it's got 3. So no. So there we go. My answer is C. Okay, good. Next, now we've got some acids and bases. All right, so you have a minute and your time starts now. Grade 12s, this one is a bit of a mean question, okay? This is a hydrolysis question. So what's actually really important here is that you know where the salt comes from. So they say to us we've got ammonium sulfate dissolved in water. Which of the following statements regarding the solution formed is correct? So remember that NH4,2SO4, when it dissolves in water, is going to become NH4 plus SO4 2 minus. Now, the important thing here is to go, well, where did the ammonium come from? Well, it would have come from ammonia, and the SO4 would have come from sulfuric acid. Okay, the sulfuric acid is a strong acid which creates a weak base. Okay, the SO4 2 minus isn't actually going to react any further. The ammonia, which is a weak base, creates a strong acid. That ammonium is actually going to react with the water again. So if we go a little bit further down, let me just put this in another color, it might be easier for you to see. Okay, so if we go back here and we go to the ammonium, the NH4 plus, it's going to react with the water again, and it's going to end up giving me ammonia, okay, because it's going to give away its hydrogen, and H3O plus. Okay, so now what that means is it's going to increase the concentration of my H3O plus ions. So we know it's not going to be a pH 7. Well, this statement can't be correct because it says less than, and we know that that's always equal to 1 times 10 to the minus 14. So now it's between the next two. The pointer is that I'm creating H3O plus ions, so the H3O plus ions is great, concentration is greater than my OH minus ions. That means it's got to come from D. Okay, you have to work that one out. Alrighty, so next one. There we go. You have a minute. Time starts now. Okay, this is quite a strange question. Okay, and I've just realized I put the wrong answer here. Now it says to you, you've got acetic acid plus HSO4 minus, which becomes the CH3CO minus ion and H2SO4. That shouldn't be there. Okay, the strongest base in the reaction is, now this is a weak acid which will turn into a strong base, okay? This, now here we're going to work backwards here. This is a very strong acid, which means it comes from a weak base, if we look at the conjugate pairs, which then means that the CH3COO minus is the strongest base in this question. It's A. All right, it's quite a weird one to look at, but this one they want to know whether you understand what happens with conjugates, that a weak acid becomes a strong base and a weak base becomes a strong acid. Okay, last multiple choice question. This is actually a really nice one. Make sure you read it properly, and your time starts, well, you're going to have a minute just like before, and your time starts now. All right, now, grade 12, when I did this question, I had to read it a couple of times before, because I made a mistake the first time. So it says the following reaction is a Lowry-Bonstead acid-base reaction. The reaction is classified as an acid-base, reaction is that. It should say the reason. Okay, that should say the reason. All right, now, it's an acid-base reaction. So ammonia is a base. Hydrochloric acid is an acid. So the hydrochloric acid is going to give its hydrogen to the ammonia. Okay, so now we look at the options. We go, NH3 accepts a proton. Absolutely. HCl, no, it gives it away. Blah, blah, blah. NH3 donates. No, it accepts. HCl donates an electron. Nonsense. Donates a proton. So that means my option is A. Okay, so on that note, we are going to do an acid-base reaction in the next segment, so take a little bit of a break, get your mind in the right place, and I will see you in a couple of minutes. Okay, welcome back, grade 12. So now we have a really nice acid-base reaction. I really like this one. So, it says to us that learners perform a titration to standardize a dilute sodium hydroxide solution, so in other words, to find its concentration. They use a standard oxalic acid solution and they give you the equation. Don't get too fussed about the dots in the H2O. That just means it's added to it. We use it as part of the molecular mass. It doesn't really change too much. Of solution of concentration 0.02 moles per decimeter cubed. The titration is repeated 3 times, after which the average volume readings are calculated as shown in the table. So, first 2 questions. What does the term standard solution mean? And give a reason why the titration is repeated 3 times. This shouldn't take you long, so I'm going to give you a minute, and your time starts now. Okay, I really hope you finished grade 12s. These were the easy ones. So, the first question here was, what does the term standard solution mean? This is a definition, okay? So, it's a solution of known concentration, okay? That's the important thing. And in order to do a titration, you have to know the solution of at least what you have to know this concentration of at least one. Now, this is a skills question. Give a reason why the titration is repeated 3 times. It's to increase the accuracy, okay, of the readings, accuracy of the readings. So because if you look at the results, okay, and you look here and you go, well, there was actually quite a big difference between 1 and 2 than the difference between 2 and 3. And in fact, I would probably say that number 1 was probably a bit of an anomaly in that it was probably not done right. And I would have preferred this to have been done a 4th time, and then we can ignore that one altogether. That would have been much better. But because we did it 3 times and we get an average, this value becomes far more accurate, okay, than we would have had before, even though I think the 20,24 is a little out, but it doesn't matter. So now we go to the next part. Says to us here, here's the balanced equation for the reaction taking place, and they want you to calculate the number of moles of oxalic acid. Now remember over here that there's the equation for it, there's the concentration, and I want the number of moles. So that's the volume I'm going to use, all right? I'm only going to give you 2 minutes to do this. So what you're going to do is you're going to calculate the number of moles of oxalic acid, and your time starts now. So, grade 12s, how many of you sitting there going, no, wait, Tracy, we're not done, I haven't worked out the molar mass, and it's such a big equation. You don't need it. You don't need it. Be careful here, okay? Because I worry sometimes that you try and do too much, because now all we want is the number of moles. Now, we know the concentration is 0.02 moles per decimeter cubed. We know the volume is 25 centimeters. Now, we can't cubed. You can't use that. We've got to divide by 1,000 because we need it to be in decimeters. Okay. Well, concentration is number of moles over volume. So that means all I need to do is do this, and it's multiplication. So my number of moles is there's an equal sign in the middle, 0.02 times 0,025, and we get 5 times 10 to the 4, to the minus 4, that would be terrible, moles. Okay, so we've got 5 times 10 to the minus 4 moles. Great, let's move on. Now, the dilute solution of sodium hydroxide used in the titration was obtained by adding 90 centimeters cubed to 100 centimeters cubed of the sodium hydroxide solution. Oh, look here. Calculate the pH of the sodium hydroxide solution before dilution. 8 marks. Oh, boy. So, I'm giving you 3 minutes, and if I do that, let me just remind you that the number of moles of the oxalic acid, okay, was, 5 times 10 to the minus 4, okay, because you're going to need that, okay, so, you need the balanced equation again, so let me write that down for you. So there's H2C2O4 2H2O plus 2NaOH, which then gives me Na2C2O4 plus 4H2O. You now have all the information you need. You have 3 minutes and your time starts now. Okay, so grade 12. So how many of you sat there and, okay, I'm not even going to try? Please don't do that. This is a difficult one, okay? I'm not going to try and pretend it's not, because it is. Now, you have to work backwards on this one because they want to know what the concentration is before we diluted it. Now remember that concentration for dilution is we use this equation, okay? We need this original concentration in order to get the pH, but before we get the original concentration, I need to know what the concentration is that we used in the reaction. Okay, so now we go, well, there's a couple of ways you can do this, okay? But looking at the relationship between the number of moles is quite important because we know how many moles of oxalic acid we had. We had 5 times 10 to the minus 4, let's put that in. 5 times 10 to the minus 4 moles. Now, that didn't change, but that number of moles will determine how much sodium hydroxide we need. So the number of moles of sodium hydroxide we need is going to be the 5 times 10 to the minus 4 times 2 over 1, because we need twice as much sodium hydroxide as we've got oxalic acid, okay? So that gives me 1 times 10 to the minus 3 moles. So in my reaction, I used 1 times 10 to the minus 3 moles. Now, why is that important? Because that's going to help me determine the concentration of my solution, okay, that I used after it was diluted, because concentration, is number of moles over volume. So we had 1 times 10 to the minus 3 moles. But what volume am I using? Because now we've had a whole bunch. I said to you that we used 90 centimeters cubed and 10 centimeters cubed, and then here we've got another volume. This is the volume I want to use because that's the volume from the equation, from the reaction. So that's the volume that we used of the diluted solution. So now, watch what I'm going to do here, because this is going to make my life a little bit easier. Instead of dividing by 1,000 and then using the decimal, I say times 10 to the minus 3. This means that my concentration now is 5,03 times 10 to the minus 2 moles per decimeter cubed. That is my second concentration. I still want my first concentration. So, and I know this is mean and I know this is horrible, but, oh, no, I'm doing all sorts of weird and wonderful things. But the point here is that this becomes a level 4 question where, well, level 3, level 4, where it becomes, because we have to work backwards, okay? So, using that, I now need my new concentration. Well, I'm going to work it out. Now, watch here. Okay, so, I know I want C1, and C2 is this. Oh, no, C2 is not that. Wow. Can you tell? It's still early in the week. I'm doing it again. Oh, my word. Okay, 5,03 times 10 to the minus 2. Volume. Okay, so they told me here that I added 90 centimeters cubed to 10 centimeters cubed of the original volume. So that's 10 and that's 100. I can change that into decimeters cubed, but I don't need to because they're both in centimeters cubed. So my original concentration is 5,03 times 10 to the minus 1. So, how does that help me? All right, now, not even finished it, because NaOH, when it dissolves in water, becomes Na plus OH minus. It's a 1-to-1 relationship. So, the concentration of my OH minus ions is going to be equal to the concentration of my NaOH, which means it's 5,03 times 10 to the minus 1. But they asked me for pH. So that means I now go, well, let's do this. H3O plus times OH minus must be 1 times 10 to, can you see why this was worth 14 marks? 8 marks. H3O plus 5,03 times 10 to the minus 1. Okay, We now divide by 5,03 times 10 to the minus 1. That gives us an H3O plus concentration of 1,99 times 10 to the minus 14. But we're still not finished. Okay, pH is the negative log of the H3O plus ion. So it's the negative log of 1,99 times 10 to the minus 14, which gives me 13,7. And I'm very happy with that number because it's a sodium hydroxide solution. It is a very strong base. And now we'll take a deep breath because that was really long. Now you need a break, so I'm going to give you a couple of minutes and then I'll finish off not as hard in the last section, okay? So I'll see you in a couple of minutes. Okay, grade 12s. Deep breaths, last section, fertilizer industry. Such an important industry. Please, 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 please do not ignore this when you're studying. This becomes your level 1, level 2, maybe at a push, level 3 questions. Okay, so this is where you get marks. So here's our diagram. It says it illustrates the manufacture of a certain fertilizer. I've seen this diagram before, so hopefully you have. Tells you we got the fractional distillation of liquid air, we get substance A, we have hydrogen, we have a process called A, we have substance B, process 2 produces something, and then we get fertilizer C. So what I'm going to do here is I'm going to break this up because I only want you to do the first 3 questions. Okay, so those are the ones I want you to look at, and I'm going to give you 2 minutes to do the first 3 questions. Okay, and I'll go back to the diagram as we go along. So you have 2 minutes and your time starts now. So, how did we do? Now, before we even tackle questions like this, and I did this deliberately, this is what you should do with this before you even look at a question. You go, fractional distillation of liquid air. The reason why we do that is that produces ammonia. Then I take, nitrogen. Nitrogen plus ammonia is actually the Haber process. Okay, because together with those, that's going to give me ammonia. Then they give me process 2, which gives me down to nitric acid. That makes that the Oswald process. And what they've done here is gone ammonia plus nitric acid means that I'm going to get ammonium nitrate. Okay, didn't need the bracket. It's going to give me ammonium nitrate. Okay. Now, when I look at this and go, well, there's a couple of things I can ask along the way. They can ask the equation for the Haber process, and they can ask me about those equations. And they'll absolutely ask you something about what it's called. Maybe they can ask us about the conditions, temperatures, equilibrium, all of that sort of stuff. So, but we've got an idea of what's going on. So now, when the first question says to us, name or formula of the substance that is obtained by the fractional distillation of liquid air, we go, oh, look, done already, didn't have to think about it, or you could have told me nitrogen. Then they say, balanced equation for the reaction that occurs in process 1. So we go, what was process 1? Process 1 was the Haber process. Now I know already that I'm going to get nitrogen plus hydrogen. Reversible reaction gives me ammonia, has to be balanced, so I know I've got to have a 2 and a 3. We don't worry about the catalyst in this one. Then they say, name of the substance B that forms as a result of process 1. So we went, oh, look, we've got it. We said it was ammonia, but now watch what this question says. Now this one says name. That means I have to write the name only. And if I write NH3, they will mark it wrong. Okay, so there's 3 more questions for this. So there they are. I'm not going to give you very long because we've pretty much done it. So I'm only going to give you a minute and your time starts now. Okay, grade 12s. You shouldn't have struggled with this because actually all the answers are here except for the last one. Because now I said to you, so this question here was name of process 2. Well, we put that in. It's the Oswald process. Name or formula of the fertilizer C. So that was NH4NO3. And they're giving you the name because they're trying to make it a bit easier for those of you that can't write the formula. Because it's ammonium nitrate. Now, the next one, and I'm glad they only asked this once, is they said, name of the process that occurs when excess fertilizer C runs into rivers. Okay, that is eutrophication. I've got to remember how to spell it, eutrophication. Okay, eutrophication. Remember, that's when we get excess nitrates, we get the algae bloom and all sorts of things. Please make sure you can explain eutrophication. It's quite important. All right, now, next question. A farmer has 2 bags of fertilizer marked A and B as shown below. Okay, so there we go. And the first question is the farmer wants to grow tomatoes and fruit. Which bag is better? And give a reason. And then calculate the mass of the potassium in bag B. So this is our last one. So I'm going to give you 3 minutes and your time starts now. Okay, so the first question is really important because it says which fertilizer must you use. Now, they gave you the hint in that they wanted the one that grows fruit and tomatoes really well. That means it needs to be the fertilizer with the biggest amount of potassium. And remember that our numbers go NP/K. So you look at the ratio. Okay, this has also got 30% more, that's only 20. And this one has got 2 parts. It's got a lot more fertilizer, and it's 2 parts out of 10. And this is 1 part out of 9. This 2 parts is far more important, so it's got a much bigger ratio. So what we would say here is that for 3.2, we would use bag A, okay, because there's more potassium, okay, and that's what we want. We want the one with the most amount of potassium. Now I'm going to have to go quickly calculate the mass of the potassium. Well, the way we do this in bag B is the percentage potassium in any bag is the number of parts of potassium, I should have given you less time, sorry, divided by the sum of the ratio times by the purity. So if we look at bag B, we have 2 parts out of 9, not 1 part of 9, and it's 20% of the purity, okay? So we have 2 parts out of the 9, so it's 2 parts out of 9, and I've realized my answers are wrong, NPK, yeah, times by 20, okay? So now I'm going to have to calculate this because I made a mistake on mine. So it's 2 divided by 9 times by 20, which gives me 4,4. So 4,44% of my bag is my potassium, okay, but the mass of the potassium in the 50 kilograms is going to be 4,44 over 100 times by 50, which means it's 2,22 kilograms of the bag. Okay, now I've run out of time quite badly. I'm sorry. Well done, guys. Good luck for your exams, and I will see you again. Bye.